Okay, we're going to work through one of these challenging math problems, okay, where we're going to figure out the molar mass of an unknown solute using a colligative property. And in class yesterday, this is when I felt the vibe of the room just like tank. And I was like, I am losing them. And I understand it was a long class. I get it. But like, bring it together. We can do this. We can do hard things. And I'll try and like write this out nice and neat in comparison to some of the chicken scratch I put up in class. Okay, let's read the question first. Make sure we're all on the same page. A solution is prepared by dissolving. It's always good when your professor uses the correct grammar. Is prepared by dissolving 2.5 grams of an unknown non-electrolyte compound in 100 grams of benzene. The boiling point of pure benzene is 80.1 degrees Celsius, and the solution boils at 80.7 degrees Celsius. Calculate the molar mass of the unknown compound, and then you're given the Kb. All right. So once you get K, okay, let's set this up. So we know we took some unknown. Okay, we don't know what it is. That's the point of this. We're going to try and figure out what its molar mass is, which is going to tell us it's a physical property of this thing that we put in. And we put it into benzene. All right. So again, we often use water as our solvent. So maybe it feels like uncomfy when we start using other things. And you're like, well, what's the solvent? And we haven't talked about water. Benzene is our solvent in this case. All right. So we want to identify that. And one thing that like points that out to me, apart from like how the question is written, is that you get the Kb for benzene. All right, so that tells me that I'm considering benzene my solvent because Kb is a solvent property. Okay, so that's another good thing to point out, that like benzene, we get the Kb, and that tells me it's got to be the solvent. All right, and I have 100 grams of it. Okay, that's going to be important later. So let's set up like big picture here. What's happened? We had this cup of benzene. I guess we're not going to cap it. Don't cap it, because then we'd have some problems here. All right. We put it on a heat source. Love a good doodle. Okay, we put it on a heat source, and this thing boils. Benzene, pure benzene, boils at 80.1 degrees Celsius. All right. And then let's grab a different color here. Okay, I'm going to take my unknown, which is going to be in the blue, and I dump the blue in, right? And I dissolve whatever this is, and it goes in here. Now, once I do that, my boiling point of this solution is 80.7 degrees Celsius. So we had an elevation of 0.6 degrees Celsius. Okay, and again, since it's a colligative property question, it doesn't matter how this non-electrolyte thing interacts with benzene. We know that it went into solution. That is assumed in the question because we say that it was dissolved in there. So we don't have to worry about whether it went in or not, or how soluble it was. That's part of the question. It went in. We know it dissolved. Okay, and we know that the boiling point increased by so much. And that has to be tied, we're going to assume ideality, that has to be tied to the number of particles that went into the solution. So we need, what we're going to figure out is how many particles we must have added. And that means how many moles must have been added. Once we have the number of moles of solute added, then we can do the last step where we figure out molar mass. All right, so we put something in, the boiling point goes up. We know through this relationship that this change in boiling point must be related to that molality. And remember, molality is moles of solute divided by kilograms of solvent. And that's what we're after. We need this. We need to know moles of solute because we need to be able to relate the moles. We need to know how many moles did we add with that 2.5 grams. Okay, once we know how many moles that equates to, that's what gives us the molar mass. All right, so now let's start putting some numbers into place. All right, we were told that this was a non-electrolyte. That is our way of sneakily telling you that I is 1. A non-electrolyte doesn't split up into ions. A non-electrolyte solution doesn't conduct electricity. That's where that electro part comes in for electrolyte. It doesn't do that. So it's all neutral in there. So that's an I of 1. We don't know the molarity, but we do know the Kb. And what we're trying to get to, as I started here, is this. We want this. So let's start by solving out for molality. Okay, so molality will equal our delta TB divided by I KB. I don't know why I put this so far away. Let's move it over. All right, so that's going to be equal to, our delta TB is 80.7 minus 80.1. That's in degrees Celsius. I was 1 on the bottom, and then we have our 2.53 degrees Celsius per mole, and this was degrees Celsius. So just as a reminder, the units work out, we're going to wind up with molality here. Okay, so I should have a calculator so that I can do this. So I'm going to have 0.6 divided by 2.53. Okay, the molality of this solution then was 0.237 moles of solute per kilograms of solvent. Okay, and we could be more specific here if we want to, just so that, like, to remind yourself, we know what the solvent is. It's benzene. All right, so that's the concentration of the solution. But right now we need to know the actual number of moles that were added to that solution, to that benzene. And to do that, we need to multiply by kilograms of benzene. Look, I can isolate moles of solute if I could just multiply by the number of kilograms of benzene I had. And we have that. That was given to us. We know that we started with 100.0 grams of benzene. Okay, so we just need that to be in kilograms. So remember that 100 grams equals 0.1000. And again, I just can't with the sig figs, but I really do try. I try for you. All right, our kilograms of benzene cancels. When we multiply through, now we have moles of solute, right? That's the thing that's left, our unknown. We have moles of solute, so 0.0237 moles of solute were added. All right, don't stop there. We have one last step. We say, okay, those moles of solute we now want the molar mass. So I know that 2.50 grams of this unknown was equal to 0.0237 moles, right? Remember, molar mass is grams per mole, okay? This was given to us in the question. We know we added that much. So 2.5 divided by that 0.0237 gives us 105 grams per mole. So that must have been the molar mass of the thing that we added. And there's that answer. All right, so hopefully that made this a little less frightening and anxiety producing, and you'll get some more practice before the exam.